You and I, we're basically living online, right? But have you ever stopped to think about what the internet actually is? It feels like it's just everywhere, kind of like magic. But the truth is, behind every single click, there's a real, physical journey happening at insane speeds. And today we're going to follow a tiny piece of data on that incredible trip.
I mean, really think about it for a second. You click on a link and a website from halfway across the planet just appears, instantly. It feels like it shouldn't be possible. But what's happening in that tiny fraction of a second, well, it's one of the most amazing things we've ever built.
That one little click, it's like firing the starting gun on a global race against time. So let's do this. Let's follow one little piece of your data, from the moment it leaves your screen, all the way out into the big wide world, and then all the way back home.
All right, so our journey starts right here, with a single click. The second you press that mouse or tap that screen, you set off this whole complex chain reaction.
See, your request to, say, watch a cat video is way too big to send in one go. So your computer does something clever. It chops it up into thousands of tiny little pieces. We call them packets. The best way to think about it is like this. Instead of sending a long letter, you're writing it out on hundreds of little postcards and mailing them all at once.
Okay, so our postcards, our packets are all ready to go. Their epic journey's about to begin. But the first leg of the trip isn't some grand global adventure. Nope, it's super local. They've got to get out of your house first.
First, your packets wirelessly jump from your computer or your phone over to your Wi-Fi router. From there, they zip through the cables in your walls, under your street, and land at a little local building that belongs to your internet service provider, your ISP. It's kind of crazy. They've already traveled a decent distance before the real journey has even begun.
But wait a minute, how did these little packets know where they're going? Well, each one gets stamped with a destination IP address. You can think of it as the exact mailing address for the server they need to find. And, just as important, it has your device's IP address as the return address, so all the info can find its way back to you.
And this is where the scale of our journey just completely explodes. Once your packets leave that little local building, they merge onto the actual backbone of the internet, a mind-bogglingly huge network of cables lying on the bottom of the ocean.
Just take a second to look at that number. Over 800,000 miles of physical cables crisscrossing the dark, cold ocean floor, literally wiring up the continents. This is the internet's circulatory system. It's a real, physical web holding our digital world together. It's wild.
So how on earth does data travel so fast through these things? Well, these aren't your grandma's old copper phone lines. The internet runs on fiber optics, these incredible hair-thin strands of super pure glass. Inside them, your data packets get turned into pulses of light, literally shooting through these glass tunnels at almost the speed of light.
And the difference is just staggering. I mean, old copper wires, they were moving data in thousands of bits per second. A single fiber optic cable can carry trillions of bits per second. That massive leap in technology is the only reason our modern world of streaming and instant everything can even exist.
Okay, so after that insane race across the ocean, our tiny data packet finally arrives. Its destination is a massive, humming, super secure building called a data center. This is the brain of the whole operation.
So, how did our packet find the one right building out of millions? Well, it had help from something called the DNS, the Domain Name System. The best way to think of it is as the internet's phone book. Before the packet's journey even started, the DNS looked up the website address you clicked, the one that's easy for humans to read, and translated it into the specific IP address that machines need.
And these places are not just some office building with a bunch of computers. They are gigantic, industrial-scale facilities. This quote just nails it. They really are fortresses, buzzing with electricity, cooled by massive AC systems, all just to keep our digital world humming along 24/7.
So inside that data center, a server grabs your packets, puts all those little postcards back together in the right order to read your request, and then finds the web page or the video file you asked for. Then it does the whole process in reverse. It breaks that file down into a whole new set of packets and sends them right back out on the road. And just like that, the job is only half done. Those brand new packets, the ones carrying the website you actually wanted to see, now have to make that entire crazy journey in reverse, all the way back to your screen.
Now this part just blows my mind. Look at this timeline. The entire round trip out of your house, under an ocean, into a data center, processed, and all the way back happens in around 150 milliseconds. That is literally faster than you can blink your eye.
It is an absolutely incredible feat of speed and logistics.
So what's the big takeaway here? What does all this mean? It's pretty simple, actually. The cloud isn't some fluffy, magical thing floating up in the sky. It's real. It's physical. It is hundreds of thousands of miles of glass cables on the seafloor and giant, power-hungry warehouses all over the planet.
This unbelievable physical network has connected humanity in a way we never thought possible. And we're still building it, adding satellites and even faster cables. It just makes you wonder, what's the next step? What does the future of this global connection even look like when this journey gets even faster? Definitely something to think about.